reading the section on 1.2 titled Using Experiments to Investigate Medical Mysteries. It's these paragraphs that you see on my screen here. So you can see that we are going to be learning about how to design an experiment and some of the key terms related to that to make it valid and useful. If you go back to the top with me, please, under Resources, I'm going to click Experimental Design. Okay. Here is going to be the information as well as examples for when you design your experiment. So you need to be able to reference back to this. Again, it was under the resources of 1.2 titled Experimental Design. All right, so the first thing that you would do when you are designing an experiment is you need to have a problem or a question. It's basically stating what is the purpose of this experiment. What are we doing or what are we checking for? It says to start designing an experiment, you must clearly state the research problem or question you want to solve. Make sure it's very specific. Make sure that you can actually test it at the end. You have to have some way to know if you have made a change or if anything has happened from your experiment. The example research question that you can see here, and this relates to what you guys will be doing, because we're going to be doing vital signs, is does performing jumping jacks for 2 minutes increase respiratory rate? Notice it has a specific activity, it has a specific time frame, and it tells me what we're going to measure. We're going to measure respiratory rate. Now this is one of the examples. So you are going to design an experiment similar to this, but you are not using jumping jacks for 2 minutes because that's your example given. But you can be creative to something similar to that. All right, so that's your statement. That is the question or problem as to what you're going to solve. Okay, step 2, you are going to predict a solution to the problem. You're going to create a hypothesis, and a hypothesis is a statement. It's going to state what you believe to be the outcome of your experiment. We know based on just life experiences what can happen to our vital signs. If you run, your vital signs are going to do this. If you sit still, close your eyes and deep breathe, you know that your vital signs will probably do this. And so your hypothesis isn't going to be anything earth-shattering. You probably know what's going to happen, and that is your statement. Now your statement, as an example, it says performing jumping jacks for 2 minutes will increase respiratory rate. So you're taking your research question. For instance, this one says, does performing jumping jacks for 2 minutes increase respiratory rate? That's the question. Restate it into a statement to what you believe will happen. Performing jumping jacks will increase respiratory rate. Okay, so that's step 1 and step 2. Please make sure you refer back to this to kind of guide you on what a hypothesis and problem should look like. Okay, now here's where we get into some terms that we have got to spend some time practicing. Okay, in an experiment, you're going to have what we call variables. I know you've heard of variables before in science and so forth. So let's tag it in here to medical detectives for an experiment. And it says, in the early planning stages of an experiment, another factor to keep in mind is the use of variables. Variables are factors in an experiment that may change. Does not sound too new news to you, I'm sure. Let's talk about independent variable. In your experiment, whatever you are changing or you're adding new because you want to see if it makes a difference in the end, that is your independent variable. It is changed by the person conducting the experiment. Okay. Then, at the end of your experiment, you are going to be measuring something. You're going to be testing the results, correct? And when you test the results at the end, that is called your dependent variable. It is the measurable effect or response that happens when you change the independent variable. Okay? The dependent variable is observed or measured. So this is our measurement at the end. If you click on dependent variable, it even says that the dependent variable, get this, depends on your independent variable. See? They all go together. Okay, so let's look at this. At the example that was given to you, it says, looking at the jumping jack experiment. Okay, the independent variable in that example is the jumping jacks for 2 minutes. That is what they're adding new or doing different. It's not something they do all the time. Okay, they now are trying to see if their respiratory rate changes after doing jumping jacks. That's independent variable. Now, at the end of that experiment, after the end of doing jumping jacks for 2 minutes, they then are going to check their respiratory rate. That is their measurable effect at the end. That's their dependent variable. Okay. So independent, what you're doing new, dependent variable, how you're going to know you made a difference at the end. All right, those two terms are going to come up a lot, so make sure you kind of get the hang of those two. All right, as you continue to design your experiment, you will see that you'll need to list any materials. Depending on what activity you guys choose to do, your materials may be just simply your iPad for time, or maybe you have other materials you're using as well, and I'll explain that in a little bit. But that's where you're checking materials list. Safety concerns. In our experiment today, we're not using hazardous chemicals, or you're not jumping from a building or anything super dangerous. So your safety concerns can just simply be like you see here, only perform in good health. You could say, something as simple as be careful not to fall and hit your head. I don't know. It doesn't have to be anything too elaborate because, again, we're not using anything super dangerous, I hope. All right, let's go talk about the control. So when I talked about independent and dependent variable, the third term that comes up all the time is a control. When completing experiments, scientists use a control for comparison. It basically is how you can compare your dependent variable so you know if you made a difference. Your control, you guys, is going to be your resting vital sign, whatever vital sign you choose in your activity. In your experiment, you are going to choose one of the 4 vital signs. I would say the one that is probably the most difficult to make a difference on in a short period of time is your temperature. But if you focus on respiratory rate, heart rate, which is pulse, or blood pressure, when you take that vital sign before you begin your experiment, that's going to be your control. And you can see that in your example here. It says the respiratory rate of the test subjects before they perform jumping jacks. Now, another way to explain control would be what the original was, what it was to begin with before you made a change. Okay.